Okay, today we are going to go over the study guide. Does anyone need an extra copy? I have the answer keys, and I'm going to post that actually right now on Blackboard. And I'm also going to post the answers to quiz 4 we did in class. And I'm going to give you back that quiz. I'm going to get you started on kind of the study guide packet. Hopefully you guys have looked at it, but maybe not. Do you need a copy of this? I gave it to you guys on Friday, but if not, I have extras. So there's going to be 4 sections on this next exam. Right? It's going to be about evenly weighted, 25% of the points from each section. I've broken down the objectives, like the end behavior. You'll be able to tell me the end behavior, and arrows are fine on that. If you want to say up this way, down this way, up this way, up this way. Example of end behavior type thing. If I ask you, choose the end behavior of the graph of each polynomial. So instead of saying rise to the left, falls to the right, things like that, you can just graph in here. It's going to go like this. Do you guys see that? Here, it's going to be like this. Okay. However, when you graph a polynomial, you're still going to have to apply the end behavior. So going back to our objective, identify the zeros in the multiplicity of zeros. That comes in on graphing as well. So there might be a question to just identify the zeros, and then there'll be a graphing a polynomial where you have to identify the zeros to get further. Apply the intermediate value theorem. Not as important. Sketch the polynomial function. There will be a couple sketching of polynomials, just like you did on that quiz. .3 was all kind of about long division and synthetic division and remainder theorem and factor theorem. So there just might be do a synthetic division or do a remainder, find the remainder, or find the value of the polynomial at 3 with not a lot of application there. Then in 3.4, we talked about finding zeros of polynomials. You might need to do synthetic division to show something's a zero. So you might use 3.3 techniques to do some problems in 3.4. And then the last section we covered was about graphing rational functions, finding the horizontal asymptotes, the vertical asymptotes, finding the zeros, finding the y-intercept, finding where the function is above the x-axis, where the function is below the x-axis, and then graph it. So this packet that I put together has pretty good example problems from each section. This packet is about twice as long as the exam, though, so I don't expect you to be able to finish it in 50 minutes. So if you think, oh my gosh, this is just a lot, I just wanted to give you every possible type of scenario that would be there. So I'm going to give you guys probably 20-25 minutes to kind of work on this. What I would suggest is do the ones you know how to do. Go through and say, I can do this one, I can do this one. I have no clue how to do this one, I'm skipping it. And then I'll kind of go over it. I've posted the answer keys to it, so I'll show you where that's at. And I also have the answer key here, and you can look at, it's not the right answer key. Anyone not sign in yet? So I have the answer key up here. If you want to come up here and grab it, or I'll walk around. If you want to check your work as you go, you can do that. Does anyone have any questions?
I have a question.
Okay.
Is that, it says graph each function, is that just the sketch the function?
Yeah, the graph and sketch the function is the same thing. The only time you're going to kind of really just kind of put like arrows is that's on end behavior. Then you don't really have to put anything in the middle. You just sketch the function. Zeros are important, the y-intercept's important, and the end behavior is important.
I just wanted to make sure I wasn't, like, that was something else.
But be careful because the wording with the rational functions, a lot of times they say graph it. graph and sketch it, it's kind of the same thing. So you have 4 different outcomes. They either both go up, both go down, one goes down, one goes up, or one goes up and one goes down on either side, right? So if I think of x to the n, say ax to the n, plus a n minus 1 to the n minus 1, right? I look at the highest term. If n is even, then I have outcomes like this, or outcomes like this. Right? This is if A is positive, this is if A is negative. If n is odd, then I have an outcome like this if A is positive, or an outcome like this if A is negative. So these are my 4 different outcomes. They're going to be both up or both down. This is your
The x.
it could be the first number, it's just the highest term. Here you have to take x times x times x squared. So really this is 3x, but it's factored.
So you don't have to add these.
No, because they're not multiplied together. This is being multiplied.
Okay.
So this is the highest term. It's even, so it's going to tell you both up or both down. And the first number is the coefficient negative. It tells you they're both going down.
Okay.
Right? Right? So both up or both down if it's even. One up and one down if it's odd. It looks like this if A is positive, and it looks like this if A is negative.
Okay, thank you.
So